We really need to take an interdisciplinary approach to consciousness studies that goes all the way back to Plato philosophy, basically. And but the problem is it's hard to find true examples of that, of true multidisciplinary science, technology, engineering, arts, and math, right? So instead of STEM, that would be STEAM, integrating all of it. And this has actually been studied. So Robert Root Bernstein, I think his name is, Michigan State University, did a study and found that Nobel Prize winning scientists are 2.5 times as likely as non-Nobel Prize winning scientists to also be artists or musicians. I teamed up with a Bay Area inventor, former Navy veteran. We've been kind of doing a rapid research and development of these random number generators and figuring out really everything that we can do with them. And so what we've created is called Halo. And basically it is, it harnesses the effects that consciousness have on the random number generators. But it is, we claim, a new computing branch, really, because we're using those for a whole suite of applications, which we call non-deterministic programming. And I'll also add that this meets the standards for what a lot of parapsychologists have been looking for a number of years, which is a device that can make large and replicable effect sizes with mind-matter interactions, or as we call it to our non-parapsychological audience, mind-machine interface, and something that is not as subjected to the decline effect because it's engaging, interactive, focuses on the local aspect of the effect, and has practical applications.
Because in general, my sense is that over the last 50 years or so of research with quantum mechanical random event generators, the effect sizes are very, very small.
Yeah, that's right. Yeah. And so part of the reason for that, a lot of the research has focused on the non-local effect. And for understandable reasons, that's exciting to think I could affect it if this is in Colorado. But in some ways, that completely misses the local effect, what's happening right in front of you. Well, if we focus on the local effect, that might actually be the key into starting a feedback loop where you have more attention on the system, the more coherent it gets. The more coherent it is, the more attention-grabbing it is, if you design your algorithms cleverly. And then that increases the mind-matter interaction effect. And so that is what Leo's invention, the ether-spheric modulator, basically a circular array of lamps that are controlled, each one controlled by their own random number generators, and very much replicably go into coherence when a group of people look at it. And we see the coherence as a unification of colors, which is statistically, I think if you have around 5 or 6 lamps the same color, that's about 10,000 to 1. And we see that on a regular basis. So this definitely works, and this has existed for years. And what we're doing with the computer is basically taking that to the next level, seeing if we can turbocharge it with machine learning algorithms.
To me, it seems as if the unique contribution here is looking at the coherence amongst a set of maybe, I think you used 10 individual random event generators, whereas in previous research studies, the researchers would use a single one and look for deviations from chance with just a single REG or RNG as they're known. And you're using a completely different kind of statistic when you're looking at coherence among several.
Yeah, that's exactly right. And the arrangement of 10, that was kind of where it all started, right? That existed. Well, I think it debuted at the Science and Non-Duality 2016 conference. So a while ago, long before I actually got involved. But together we've kind of taken that idea and, we're working on bigger and better things with it too. So at the Apparitions Music Festival, for example, we had two big LED panels that we put in front of stages. And the Apparitions Festival is kind of like a small underground rave that's in Mexico every year. And we've been going there the last 2 years, but only the last year is when I've really been involved. And we basically took LED panels and took that same concept of individual, similar to Celeron mind lamps, nodes that each have their own colors, and then putting that on 2 big LED panels. And you're right, the statistics with that are very different. Well, no, they're not very different. It's still the same idea. You look for coherence. But the particular thing that I look for in that arrangement is autocorrelation of colors. So when you get a nice gradient of colors that are, let's say, like looks kind of like a rainbow, so like a gradation as opposed to just random colors in sharp contrast next to each other. The way we can measure that mathematically is something called spatial autocorrelation.
To be clear for our viewers, each individual random event generator is connected to an output that could be, I think, one of 5 or 6 or 7 different colors. And now you've got, let's say 10 of these, and you're looking for some sort of coherence amongst the different colors in the display itself. Like they might all be the same color, or they might all show a gradiated pattern like a rainbow.
Exactly. Yes. And this is something we see replicably. This is a replicable effect when people are looking at it and people meditate around it. People don't even have to be meditating. I've seen it go into coherence just looking at it for long enough.
I've seen some of your statistical graphs. You've been able to compare your results with a larger database of RNG studies going back for decades, I think. Well, now another really interesting application that you're looking at has to do with music. If people can listen to music, and the music is created by random event generators, you've studied music. You know that certain sequences of musical notes are more pleasant to people. So could people influence the random event generators to produce music that is more pleasant to the ear?
That's exactly, yeah. So everything we were talking about with the lighting, you could apply that to sound. Really any form of art. It doesn't have to be light. Anything visually or orally engaging. And so, I basically developed a music counterpart to the lighting unit, which involves, well, there's a couple of different templates right now, and some of them are still in development. But right now I have 2 different styles. One of them is a meditation drone-like sounds, right? So that just kind of plays a major chord in the background, and there's some pentatonic notes over it that are determined by the random number generators, just for melodic interest and fill. It's not in any particular meter, it's drone music, so it's just kind of freestyle. It just goes at its own flow. But what motivates coherence is that when there's a spike in data, when there is a spike in the random event generator, and it goes into coherence, then that will modulate the drone sound counterclockwise along the circle of fifths for any musicians out there. And that is, as we know, very pleasant in that type of drone music especially. So that motivates the listener. And the key is really that it sounds good on its own. Even if, let's say, Daniel Dennett's view of consciousness was correct and that there was no effect with the random event generators, there would be no, it would still work. It would still sound pleasant to the ear and it would occasionally modulate. It's just that it works better when you throw on the mind-matter interaction. I would say, like conventional computing, there's really an infinite amount of conceivable applications with this type of computing. We're not limited to lighting and sound or even any kind of senses, right? This can go into, and we're already developing it with a number of other applications too. And it works the same way. It's still that same feedback loop. You have something engaging, and then that drives up the effect sizes, which is in contrast to, kind of the standard approach of, well, let's figure out how to replicate this a million times, right? And then maybe from there we'll figure out how to develop applications, right? Whereas our philosophy is actually developing applications is part of the key to increasing the effect sizes, which is what a lot of these researchers are looking for.
Going back to the study you did at the Apparitions Festival in Mexico, I think it's worth pointing out that the effect sizes that you achieved and reported on were greater than, as I recall, 90% of all of the previous random event generator studies done historically based on that meta-analysis that you compared your work with.
Another interesting thing from there, and this would also kind of go against the decision augmentation theory, is that there was a strong correlation at about R of around 0.2 or so, if I remember correctly, with crowd size, number of people on the dance floor looking at the device, right? I took regular head counts of that throughout the festival and then compared that to 15-minute sliding windows around that. And that correlation was there pretty much no matter how I looked at it. So, and you could say that's another form of an effect size if you have a solid correlation between two variables, and that the coherence is happening when you would expect.
It sounds as if what you're saying is that when a group of people come together, such as at a rave, where they're dancing, they're experiencing the music and the lights, and for all we know, they're also in an altered state of consciousness through some substances, which are very common in these events. And so the people themselves are entering into a state of coherence through their dancing. And at the same time, the random event generators are also entering into a state of coherence. So you're looking at a whole new way for humans to interact with random event generators.
Yes, yeah, and we're not limited to festival environments of that type. This has been taken. My research partner has taken these displays to art galleries, art shows. He actually says that is where he gets. And I've looked at the data too and been able to verify this, is that art gallery events is really where you get a lot of coherence.
One of the findings that I've noticed in my decades in the field of parapsychology is the idea of novelty. Anytime you introduce something novel, different, new, exciting, people get aroused, I guess, and they enter into a psi-conducive state of mind. But very often, if you try and repeat it, you're losing the novelty. And so many experiments start out really well, and then over time, scores decline. I would think,
effect, yeah.
Yeah, that this is something that you, even with the exciting work that you're doing, could also potentially affect your work.
This has been going on, this line of research, especially with the AIM device, for a number of years. And, I would say since 2016, it's been taken to about 400 different individual events, and there has not been an observable decline. Now, that doesn't mean that we're not affected by the decline effect. We certainly could be, especially in cases where you have some kind of cognitive overload. You start to not believe the effect yourself, or the task just wears off. And but yeah, so our approach is really to keep it novel continuously keeping in that fresh source of novelty, exploring new things, trying experiments in different ways. And, that's kind of the military style of research and development that, that we're taking from Leo's perspective and background. And it seems to be working.
So you're also looking at other applications, I believe.
The fact that we're using the random number generators, which are a quantum source, and doing computing with it, by definition, in a way, makes it a sort of hybrid quantum computer that can function at room temperature, which in and of itself is, nobody's really come up with a way to do that. Typically, you have to cool computers down, or at least the core quantum processing parts, down to near 0 Kelvin if you want to get bit entanglement and doing stuff. But we're taking advantage of the chaos effect to do computing. And so just like conventional computers have kind of an unlimited amount of applications, I would say the same thing for this type of computing. And so we've kind of taken our key interests and things that are part of our lives. So for me, I would say that's music, other than consciousness studies. I would say for me, that's music, weather, and aviation. For Leo, that's poetry. He's an award-winning poet, encryption and blockchain, and also he was an art dealer for a while. And so we kind of combined our interests and developed different applications along those lines. Now, like I mentioned at the start of this interview, we've been exploring a weather-related application with this, a weather influence-related application, where we take a forecasting model and initialize it with the random number generator, right? And we can add that kind of to the back end of our visual feedback that's in the front. And like I said, the machine learning, all of that happens in the background that looks for coherence. And we can take that and initialize the model. And with that, the first test we did went pretty well. We were able to get Hurricane Laura in the Gulf of Mexico that made landfall in Louisiana about 6 weeks back. We were able to reduce the track error in the model at landfall by about 12 kilometers or so.
It seems to me that what you're really doing is you're taking what could otherwise be a sort of dreary research task, and you're turning it into something of a toy, even that people can play with.
It is. People can definitely play with it, and it's kind of, I think of it as kind of an inner space shuttle, right? And so there's a lot of talk about how, in the last 100 years, really, the trend that's been happening in even mainstream science, away from pure materialism into more, okay, we can take mental phenomena, mental states seriously. Really, just in the last several decades, that shift has been more prominent. And especially now with mindfulness, meditation research kind of being mainstream, although mind-matter interaction, not quite yet. So this is kind of an inner space shuttle that can, because we have, in addition to the computing side of things, glasses, headsets, and with just the lighting and sound on its own, can help you achieve deep meditative states that normally take people years of practice to get to. And so this can not only give people moments of peace when they're needed, especially now during this kind of crisis, but it can also serve as a scientific instrument of discovery. I like to think about, you can study space with the telescope, but the invention of the space shuttle, that in and of itself doesn't mean there's not more science to do and more discovery, but it makes space exploration a whole lot easier because it can get you to places, it can get you to states. So this is kind of like an inner space shuttle.
A space shuttle for the mind.
That's a good way to think of it.
Well, Danny Caputi, it's been a pleasure to be with you. You're doing cutting-edge work, and it has the potential to help parapsychology take a big leap forward. Danny, thank you so much for being with me.
Thank you.